named as like OpenCodeInterpreter, which is like integrating code generation with execution and refinement. So, like briefly talking about this paper basically deals with use of the open source models with the execution and the refinement, iterative refinement of the prompts, as we all know that open source models are not that much close enough with the closed source models such as like GPT-4 or GPT 3.5 or so. So so as I mentioned that like although the code generation task is like one of the most vital challenge within the computer science, but there has been a lot of like advancement in the with the introduction of large language models, and hence we can and also the use of this instruction tuning methods within the large language models. But still the open source models lacks the execution and the iterative refinement capabilities as compared to the closed source models such as the GPT-4. And hence like even how about like doing with how about using the capability to utilize this feedback for refinement. So this paper basically deals with uses of the refinement and the execution capabilities of the open source models. So as you can see with this figure one, like just a user inputs like, okay, implement a specific function in Python, and then the output is given, and then it checks whether like um, it has any error or not. And this error is taken into account, and then a new answer is generated. And here we can see that the execution result turns out to be true. So finally the program is like working and it's correct. So the next time the user again asks it to make this function more maintainable, and then hence it improves its maintainability. So with the figure one, you can also observe that there are like certain terms like singleton and with execution feedback and with human feedback. So basically, they have utilized two types of two types of feedbacks. The first one is the execution feedback, which is basically includes the execution outputs and the diagnostics. And this execution feedback actually plays a much more role in figuring out or rectifying the synthetic or logical errors, whereas on the other hand they have utilized this with human feedback, which is basically to um, improve the generation of the solutions, and like that could be more closely aligned to the user's expectations. So you can observe that the this open code interpreter could perform much like slightly better than GPT-4, and um, with the like 33 billion parameters. So for that, like they have actually introduced the data set over here. So the data set basically is crafted in such a way that it meets the following criteria. The first one is like it should be diverse and challenging real world queries, because it should comprise of all the real world queries, so that the task should be in a variety of way and has like a lot of diversity in it. And they have like structured it with multi-turn dialogue structure, because we need to incorporate with the execution feedback along with the human feedback also, and so that like the execution feedback could diagnose why the error is caused, and hence we can use this feedback to improve the solution. And then they have also interviewed the text along with the natural language natural language text plus along with the code responses, so that like it could offer a much more holistic approach in order to solve any kind of coding queries. So they have actually to get this uh, this data set, they have actually utilized the few existing instruction tuning data sets that is open source, like such as like Code Alpaca or like Maggie Coder, etc. So like just going with the structure of this data set, we can like see that each one has a prompt and a completion. Here completion refers to the output, and the prompt could be taken here as a query given to the open source large language model. So this, like here also, like this is another data set. So here they have utilized this problem and as a query, and the solution is the um, output. So in this shared GPT also, like you can see that the value, I'm sorry, the value is the query, and like this is just the example of how the data look like, which they have used for defined for the um, instruction tuning pre-existing data sets. So they have like as I mentioned before that this data sets do not have like this multi-turn or execution feedback or human feedback, whereas this code feedback, because they have utilized it, they have all those multi-turn and execution feedback and human feedback. So how did they get this multi-feedback could be like looked from this section. First is like they have used this open source code instruction tuning datasets, which is like code alpaca, maggie coder, etc. And then they have done the query filtering. This is done with the help of the open source chat model, which is Quen 72 billion chat, in order to effectively select effectively filter the process in order to get only the complicated or which is much more detailed query, so that the large language models could be in a much more realistic way. And they have even utilized the use of the prompt, like two types of prompt to rate the queries from 1 to 5, and each and they have selected only ratings which is like 4 or 5 only, in order to focus on the difficult problems only, and that's how like the challenging query pool is created. And then they have used this single turn packing and interaction simulation, which I will be telling in the next slide. So for the single turn packaging, so like we almost like extracted 150,000 the high quality of the single turns code. So what we have to do is like in order to get multi-turn data, we have to group single turn query responses into multi-turn format, and this could be done using by consolidating the similar sequences in order to like, because we know that like the similar single prompt will be somehow related to each other, and they have actually utilized this bird-based embedding in order to convert the queries into vectorized representations, and they have utilized this nearest neighbor algorithm in order to identify the uh, four closest counterparts, and in which they have only selected like 2 or 3 to get this multi-turn sequences. And like it should be noted that once the query is selected that like as a neighbor, then it is not used for the future selections, and hence like almost like from 105,000 single turns, it turned out to be only 16,000 multi-turn instances were derived from the single turn packaging. And the next step was to get the interaction simulation. In here, what they have done is like in order to gather the human interaction data. So they have first just given like for a given query, they have just used this GPT 3.5 to generate the preliminary response, which then extracts the code snippet and then execute it. And the executed result was used with like the outcome of the execution along with this compiler diagnosis was then fed into the GPT-4 in order to get the follow-up response, and this was done until the correct solution was made up. But the maximum iteration was set to 3, and if it's not, then the correct solution was not made. And then the last step is the code correction. And so in the code correction process, what they have done is they intentionally asked the GPT-4 to produce the incorrect code snippets, and then like along with the error messages, they try to get clues for the corrections, and that's how like they replace the initial prompts with like that actually resulted in the incorrect code with the ones like that encourages the generation of the correct code output. So in this way, like uh, the model is also being getting to know how the how from the incorrect code it can move towards the correct solution. And for the last step, they have even like utilized this lead code data sets for the data set generation. Firstly, they have used this lead code similar problems. Like this was attained with the Taco data set, which was like publicly available, and it actually categorizes each related questions through tags, and that's how that makes it easier to utilize this data set. And hence, like this data set is cleans in order to prevent any kind of like unintended impact that could be attained from the benchmark data sets such as like human eval or MBPP. So and the next one is like so every lead code data set has consists of this follow-up questions. So in order to do that, like because the follow-up questions have to like to isolate the solutions which are like that just differ in time or space complexity. So they have used this, and they have also added the natural language explanations using this GPT-4 because leak code problems, like the solutions often lack this explanations of the code. So this was all about the methodology of like how they have used this model is there. And now I'm moving towards the experimental. So before I move on towards the experimental, like this was basically trained on two types of models. The first one is the Code Llama, and the second one is DeepSeek Computer. And um, roughly speaking about DeepSeek Coder, this is like it consists of like two languages. This model consists of two languages, like that is English and Chinese, the um, and like the data structure somewhat looks like this only, like the instruction and the output. So um like like similarly like the data structures of the other fine tuning other instruction tuned prompts. So and there are like the three types. The first one is like execution feedback, which was actually diagnosed with the compiler, and the second one is the synthetic human feedback, which actually like generates like the tries to generate like human input by considering the task description. And the second one is the synthetic human feedback oracle, which actually uses uses the ground truth results while with the GPT-4. And as you can see that the this open code interpreter could perform with various like from the various pre-trained models also, and along with the open as well as the closed source models much more better in terms of like in terms of its accuracy. And towards the another experimental result which they have said is like in this they have like this is the performance of the open code interpreter with the mixed ratios of the single turn data and the code feedback data. And here we can observe that that if we use high quality single turn data improves the multi-turn performance, and hence like the use of the multi-turn is much more efficient and significant strategy. As well as like we can even observe that the use of like single turn packing along with this interaction plus the code correction like improves the performance with the use of this execution feedback. So hence like it do shows that there like if we have a diverse multi-turn data sources, it do have a better impact in the correction of the. So in conclusion, like we can say that this open code interpreters have like given a significant lead in the code generation task, as well as like it has like also adapted the capability of the opens uh, of the performance similar to the closed source models like which like such as GPT-4 or mm, other open closed source models, and it has also introduced the multi-turn interactions datasets, which actually uses this human feedback along with the execution feedback in leading to the better execution results. That's all. Thank you. Is there any question?
네, 질문 부탁드립니다. 저희 내부적으로 세미나 할 때도 여쭤봤던 건데 그 딥시 코더 모델에 대해서 좀 파악이 됐나요? 그 코드 람마보다 훨씬 더 비슷한 사이즈의 모델인데 성능이 좋은 걸로 나오는데 어떤 어프로치를 썼길래 그런 건지.
Because I think maybe the data collection, like they have used this data collection from the GitHub, like they tried to remove like line length by filtering it, and then like they have even filtered with the like converted most of the Jupyter notebooks to scripts. In that way, like because of the data collection, the performance was better. Like what I felt was.
알겠습니다. 그러니까 데이터 컬렉션 방법이 더 뭐 또 그 뛰어났다는 얘기인가요?
Yes. And like they have like used this like in their data set they have used like almost 90% of the code along with like 10% of the natural language text.
Yeah, but I think that's the same for the code llama model.
Yes, but the data collection was the main reason what I felt
Yeah,
the
so my
most.
question is how is it different from, the way, code llama is trained?
Uh, mm, mm, mm.
확실하지 않으면 답변하지 않으셔도 되고요. 또 한 가지 궁금한 거는 저 코드 람마에 대해서는 이제 익스큐션 피드백만 가지고 학습을 시켰고 저 딥시 코더에 대해서는 추가적으로 그 휴먼 피드백을 시뮬레이션한 데이터로 더 학습을 시켰다고 나오는데 왜 그 DS에서만 그러니까 딥시 코더에 대해서만 그걸 했는지도 나와 있나요, 논문에?
They have not mentioned about it, like why they have not done with the DeepSeek coder.
Okay, I see. So you got a question in the chat.
Why they have not used like COT and just utilize this execution and human feedbacks. Like just with my case also, like if I just think about like my perspective, maybe the COT would be beneficial, but like it should have this like not only because most of that the time the description or like the reasoning is not enough. We even have to get the why the error has been caused for the later cause. That's why execution and human feedbacks are also necessary, and I think we can improve it with the use of chain of thought approach.
이게 사실은 저 7 빌리언 모델이 챗GPT 4보다 심지어 거기에 코드 인터프리터를 쓴 거보다 성능이 이제 뛰어나다는 거니까 그거는 사실 성능 측면에서 봤을 때는 되게 대단한 것 같긴 한데 뭐 기술적으로 사실 엄청 재밌는 건 없다고 생각이 되거든요. 지금까지 봤을 때. 뭐 아디티가 생각했을 때 이 논문에서 뭔가 좀 더 저희가 뭐 얻어갈 만한 그런 그 새로운 기술이 있는 건가요?
You mean like, why did I choose this paper?
Yeah, it's not only about that. So what should you learn from this, the paper? So what's the new method or new insight that this paper proposed? So I just think the performance is very good, even with the small number of parameters compared to GPT-4, for instance. But it's all about the data processing, right? So data collection,
Or
especially using the ChatGPT, and nothing technically very challenging or special, right?
yes, just the utilization of this execution and this human feedback, so just to improve the performance. But like, yeah, with this paper, we can even like think of using this DeepSeek coder, which is like open source model for fine tuning the like in any certain task.
Okay, but that's just another baseline. So
And
not very kind of interesting. Can you maybe apply this method to the complexity prediction, for instance, or grammar generation?
mm, mm, I think for the grammar generation, it would be good because we will get this why the grammar has the error, and we can ask for the improvement
And
because
such data can be automatically generated
yeah,
and collected, right?
yes.
Why not for the complex prediction then?
Uh, like the reason why more with the test case generation was because with the test case generation, the main problem was sometimes the format of the GPT doesn't understand. So if the format is wrong, then we can like give it the multiple turns and also like get this execution feedback along with the human feedback, and even with the complexity prediction also we can utilize this like with like repeatedly with the human execution like to make it much more like accurate, like just for the lens.
Thank you. Thank you. 예. 질문 있으신 분들 질문해 주시고 뭔가 다들 이 BR의 세미나를 뭐 정기적인 예, 뭔가 아, yeah, question from the chat.
No, it's just in the archive version, and it has been uploaded on 28th February 2024.
제가 논문 제목으로 구글에 검색해 봤을 때 저 오픈 리뷰가 뜨는 걸 봐서는 분명히 뭔가 어디 서브미션 돼서 리뷰 중인 것 같긴 한데 이게 파악이 잘 안 되고 있긴 합니다. 네, 방금 아디티가 말한 것처럼 2월 말에 아카이브에 올라왔고 굉장히 최신 논문이기 때문에 어, 뭐 퍼블리시는 안 됐지만 뭐 같이 공유할 만한 내용인 것 같아서 공유를 드리는 게 좋겠다고 생각을 했고 또 이제 오픈 소스 모델이다 보니까 저희가 연구할 때 뭐 코드 람마보다 더 직접적으로 잘 사용할 수 있는 모델일 것 같아서 예, 재미있을 것 같아서 예, 발표를 부탁했습니다. 뭐 기술적으로 엄청 새로운 게 없다고 하더라도요. 예, 그 혹시 또
Like as you said with the figure one, but figure one is just the example. Like it was done until it like get the exact answer, but the maximum was only 3 iterations.
So only three? I think the figure already has four.
But it is not the human interaction. The first two is the execution interaction.
Oh, I see. So excluding that, the execution result.
The human interaction is 3 times
Okay.
maximum.
만약에 또 질문이 없으시면 오늘 아디티 그 좋은 발표 감사드리고요. 고생 많으셨습니다. 그러면 또 다음 주에 뵙도록